Hello, this is Lily, and in this video, I'm going to explain how to make a standard solution. So we go through calculation and we make a solution using a virtual lab from Royal Society of Chemistry. But to start, first we need to know the definition of titration. Titration is a method of volumetric analysis in which we use the concentration of a known solution to calculate the concentration of an unknown solution. In this video, we want to focus on acid-base reaction. And we know when one acid and a base reacts, the reaction named neutralization reaction, and they make salt and water. So we have acid plus base always give us salt plus water. Let's say I have a known concentration of this base, known C, and I don't know the concentration of this acid. But I have a certain volume. I know the volume, certain volume. And I want to see what volume of this base can neutralize a certain volume of this acid. And using that, we can find concentration of acid. In this video, I'm not going to explain how we do this calculation. It's the subject of other video. Our focus in this video is on a standard solution. To correctly find the concentration of this acid, we need to have a base with correctly known concentration. It means we need a standard solution. But how we can make a standard solution? To make a standard solution, we need a primary standard. What's the primary standard? Is a chemical with the following characteristics. Large molar mass to minimize weighing errors. In addition, it shouldn't pick up or lose moisture. It shouldn't react with air, and it should be obtainable in a very pure form. The students wants to make 250 milliliters, 0.1 mole per liter Na2CO3 solution. That this sodium carbonate is our primary standard. We want to calculate amount of sodium carbonate that we need. Okay, so we start our calculation. After that, we go to virtual lab to do the experiment. The first step is to use the formula C equal mV to find the number of moles of sodium carbonate that we need. C equals 0.1, V equal 250 milliliter, that I need to convert it to liter, that is 0.50 liter. Just I substitute these numbers, and N is equal to 2.5 powers moles of Na2CO3. Then I use this formula to find mass of Na2CO3 that we need. So N equal 2.5 times 10 to the power minus 2. M for sodium carbonate is equal to 2. So we need 2.6 grams of Na2CO3. Okay, so we want to weigh the amount of sodium carbonate that we need, that is 2.6 grams. So I put my weighing board on the scale and tare it, and then I start adding sodium carbonate to that. 2.6 grams of sodium carbonate, just we need to pour it in a beaker now. This is our 2.6 grams of sodium carbonate, just I need to transfer to this 250 milliliter volumetric flask and then add water to reach to this calibration line. So we start. Firstly, I add some water to this sodium carbonate to dissolve it. Then I use a funnel to transfer my solution. I make sure that I rinse this beaker so I don't have any sodium carbonate left in beaker. Right now I'm close to calibration line. From now on, I use a pipette to add water because I don't want to overfill it. If I do, I have to redo all my experiments. I add water slowly because the bottom of the meniscus must be just touching the calibration line on the flask. Still, you can see the bottom of meniscus hasn't touched the calibration line. Maybe one more drop and one more. I think it's perfect now. So our standard solution is ready. Just we need to put the lid of flask and shake it to make sure all sodium carbonate is evenly distributed in the flask.